Similarly, bottom gating system. So as we have discussed the top gating system for time required to fill the casting of a top gating system. Similarly, bottom gating system. So if the gate is below, it's about the bottom of the casting, then it is called bottom gating system. So in this, what is the formula to use to calculate the time required to fill the casting cavity? So if you look at the this is, it's like, for example, this is one casting mold. This is like looks like bottom gating system, where it is mold, sand mold, and as usual this is sprue, and this part is runner, this one is casting. This is bottom gate because its ingate is at the bottom of the casting. This part is ingate. This is pouring basin, where you pour the molten metal. So here, for calculating the height for velocity, so you have two heights. If you look at this, one is this one, h1, and another one is this part. Why we need to take two heights here? Sometimes even you can some calculations, even you will get with h1 maximum value velocity, and sometimes you need to use average value. Some textbooks, actually each textbook assumes they differently, assumptions are different. Why we need to take is, see, because as the casting, like casting cavity goes on filling with the molten metal, so the height, the head, potential head of the liquid goes on decreasing, so the velocity also goes on decreasing as the head goes on decreasing. So that's why as it is goes on filling the casting, so head goes on decreasing. So we won't get exact value of velocity, so we will get variation of velocity from minimum to maximum. So we take minimum value and maximum value, we will take the average velocity. So why we need pouring time, filling time of the casting. Filling time equal to volume of casting by area, minimum area and max, and area is minimum area, which are like we have discussed already in top gating system. A minimum of pouring basin area, or minimum of ingate area, minimum of runner, runner, ingate, pouring basin, lower base, whichever is minimum, we have to take that minimum value, because we are taking average maximum velocity. So but instead of maximum velocity, we take here average velocity. V average equal to V max plus V minimum by 2. This is one way of solving the problem. It's not like always same thing. Sometimes there are different methods, like this is one method. V average equal to V max plus V minimum 2. V max equal to root 2 G H1. V minimum equal to root 2 G H2. So this with if you use a bottom gating system, advantage is there is no sand erosion. So most of the castings use bottom gating system, especially large castings. So sand erosion will be eliminated. So for filling time, some textbooks follow some different formula like A minimum into V max. Only they take V max. Why means sometimes the head V minimum may be 0 or near about 0, so they won't even consider, neglecting V minimum. So you have to try different options based on the whatever the option whichever satisfies out of those two is the answer. Generally they won't give both the answers, so only one of these two will be satisfied. If you try with V average and you try with V max, one of the method you will give the answer, and both answers won't be there. That's what I am sure. Okay. This is about bottom gating system. There is another gating system like parting gating system. So parting gating system is combination of instead of bottom or instead of top the gate it has to be in the middle of the casting. That's a combination of top and bottom gating system. So I mean, if you want to solve that one, you have to divide that into two parts. Like for example, so here the gate is so ingate is at the middle, so you need to divide this into two parts. So one is like if you draw a line like this, so consider this one as bottom gating system, this two as top gating system. Here pouring time or filling time of the casting is filling time T equal to T1 plus T2. So again same method, like you have to consider the height of the mold and H1 H2, substitute the same formulas. T1 equal to similarly volume by A into velocity. You have to use the same formula whichever we have discussed in above, okay, for both. There is another step gating system. Step gating system. So here there are more number of gates. Instead of single gate, multiple number of gates. The casting is like in one plane, it's not like vertical. So one plane, suppose for example this is one plane and this is one gate, and this one is one gate, this one is one gate, this one is one gate, like this n number of gates. So on. So there are so many number of gates, which if there are multiple number of gates, this is used for very complex huge casting, the casting size is huge, then we go for multiple gates instead of a single gate, large casting, especially machine beds. So here time required is pouring time or filling time is equal to volume of casting divided by number of gates into area, minimum of area into velocity Vmax. N equal to number of gates. So generally they ask only top and bottom gating system. They didn't ask parting and step gating system. So this is about gating system and pouring or filling time calculation. So next is solidification time. Once you pour the molten metal, so how much time it will take to solidify? So solidification time calculation. So that is also one important where they ask frequently questions, especially 2 marks question in GATE. Solidification time actually it's related to the heat transfer concept. So time taken for the converting molten metal into solid phase is called solidification time. Here we consider only that much. Time taken to convert molten metal to solid phase is called solidification. So this is the formula for this is calculated based on the heat transfer with the unsteady state conduction and heat transfer of liquid molten metal unsteady state infinite wall thickness problem, considering as that one. So after simplification, solidification time Ts equal to directly proportional to V by As whole square. Solidification time is directly proportional to V is volume of casting. If volume is more solidification time. Anyway, it makes sense also because it takes more time to fill. To solidify the molten metal. Area is surface area. More area, that means it is more exposure to on a surface. So cooling, more surface area means less time it will cool. Ts is solidification time. So T tau s equal to K into V by As whole square. K is also called mold constant or solidification factor, some different names. Some textbooks gives in some names like some constant value. So this constant value they give in problem and you need to substitute only volume and surface area. Once you substitute that, you will get the value how much time it will take for solidification. This is one of the important problem where they have asked more number of times in GATE questions. If you look at the problems in GATE, just we will solve 3 problems in GATE where they ask solidification time concept and as well as filling time concept. In GATE they asked only mostly in gating system also they asked. So in 2010 they asked about gating system. I think we may have discussed it, gating ratio. Similarly 2007 question number 6, in gate material ME 2007. So here the volume of cube of solid cube of side L and volume of sphere of R, sphere of radius R, are equal. So volume of cube he has given that equal to volume of sphere. Both cube and sphere are solid and of same material. They are being cast. The ratio of solidification time of the cube to the sphere. Ratio of solidification time of cube to solidification time of sphere. Here V by AS cube by V by AS, solidification time is proportional to V by AS whole square. So that's why we have used here V by AS. So volume is both are equal. He has mentioned AS of sphere by AS of cube. Surface area of sphere is 4 pi r square whole square. Cube is 6 L square whole square. So if you simplify this, so this one is 4 pi r square. If you simplify this, you will get 4 pi by 6 whole square, this is constant, into r square by L square whole square. So option, which one answer is? Answer is option D. Simple question. Whatever he has given condition, substitute that. He has assumed that volume is constant, so cancel V, then we will get only surface area. So 2 marks question, that one it won't take much time, so we can solve very fast. Similarly, he has asked 2006 question number 9. ME 2006. In a sand casting operation, the total liquid head is maintained constant such that it is equal to the mold height. The time taken to fill the mold with top gating is TA, and if the same mold is filled with the bottom gate, then the time taken is TB. Ignore the time required to fill the runner and frictional effects. Assume atmospheric pressure on the top, the molten surface, metal surfaces, and relation between the TA and TB. So if you know the calculation of time required for top gating and bottom gating, then you can solve. Next is the question he has given is total liquid head is maintained constant. So for that you need to just draw a simple diagram to understand. For example, take starting case, consider as a top gating system. So take this one as simple case, and we'll just draw a simple diagram to understand the problem what he has given. Don't take it as ideal diagram. So this one is height of the mold H, and this is also H. So this is a diagram. For this velocity, so time required TA is time required for top gating, time required to fill, time required to fill top gating system. TB is time required to fill bottom gating system. So TA equal to V by volume is constant, A minimum is constant, velocity of top gating, velocity of A. TB is the same diagram. If you keep the in gate in the bottom, then volume by A minimum into VB. So substitute VA equal to root 2 GH and VB equal to root 2 G, here 2H. This is important. So if you substitute TA by TB equal to, after simplifying volume and A cancel, then VB by VA equal to root 2 into root 2 GH divided by root 2 GH. I have taken that root out. Cancel. TA equal to root 2 TB. Answer is C. Answer is C. 2 marks question. If you know the concept of top gating and bottom gating, then you can easily solve this. So that's about few problems, and anyway we will do another one or two problems in calculation of filling time or solidification time. If you look at the question number 11, it's a gate ME 2005. They have asked a mold has down sprue whose length is 20 cm and the cross sectional area at the base of the down sprue is 1 cm square, and the down sprue feeds a horizontal runner leading into the mold cavity of volume 1000 cm cube. The time required to fill the mold cavity will be. So he has asked time required to fill mold cavity. To fill mold cavity or casting cavity, both are same. It equal to filling time equal to volume of casting divided by A minimum into velocity. So filling time equal to volume. He has given volume of casting is 1000 and area is 1 cm square. Velocity is you have to calculate based on 2G. H has given 20. Down sprue whose length is on the cross sectional area of the down sprue. So we have taken that length of the down sprue itself as height. So after substituting all the values, you will get 5.05 seconds. Filling time. Answer is B. Next, question number 14. Two marks question, 2003. With the solidification factor, he has given solidification factor equal to 0.97 into 10 power 6 second per meter square. Solidification, he is asking solidification time. for spherical casting. Of diameter 200 mm. Solidification time equal to Ts equal to K into V by As whole square. V equal to volume of sphere, 4 by 3 pi r cube. R is the radius of the sphere. Surface area equal to four pi r square. Substitute all the values. 0.97 into 10 power second meter square into V volume. Substitute 4 by 3 pi, diameter is 100, divided by 4 pi r square, 100 square. Substitute the value here and the answer you will get is solidification time equal to 1078 seconds. Simple, the direct substitution. Similarly, there is another question, is question number 18. GATE 2001. Again two more questions. The height of the down sprue is 175 mm. Height equal to 175 mm. Cross sectional area at the base is area of cross section equal to 200 mm square. Cross sectional area of the horizontal runner is same, 200 mm square, so you can take any of them. Assuming no losses, indicate the correct choice for the time required to fill the mold cavity of volume. Volume is 10 power 6 mm cube. Use G equal to acceleration due to gravity meter per second square. He is asking time required to filling time. Filling time Ft equal to V by A into velocity. So here volume he has given 10 power 6, surface area 200 into root 2, G he has given 10, H he has given 175. Substitute the value, we will get answer 2.67 seconds. Answer is A. Simple question. Next concept is riser design. So riser design is acts as a reservoir to supply molten metal to compensate the liquid shrinkage taking place. So that's why riser design is one of the most important crucial step in casting. So riser acts as reservoir to supply molten metal for compensating liquid shrinkage. So riser design, the basic condition is necessary condition